This recording is on the lecture that goes with Chapter 4. In Chapter 4, we cover selection structures, decision statements, specifically the if-then statements and the case statements. In addition, we're going to go over logical and relational operators and menu-driven programs. So we're going to start off with the selection structures. There's three different types. There's a single alternative, which is a simple if-then. There's a dual alternative, which is an if-then else, and there's a multiple alternative, or the case or switch statement. For this class, we're not going to go into a lot of details about the case or switch statements because Raptor doesn't really like it. However, if you want to use that in your pseudocode and then switch to a more traditional if statement in Raptor, that is fine as well. So we're going to step through each one of these. We're going to start with our single alternative. What we have here is we have our syntax for the if statement. The if is a keyword, then you have your condition, followed by the then. All of this is to be on one line. At the end of your if, you'll have the keywords end if. That will designate that this if block is done. And between those, you will have a statement or multiple statements. You can have as many as you want to. So the example we have here is, please enter your grade for project 1. So that's going to display to the user. We have our input grade. And then what we're saying is that if grade is greater than or equal to 75, then our condition here is grade is greater than or equal to 75. If it's greater than or equal to 75, then we're going to set our variable pass to the value yes, and we're going to display you passed, and then the if statement is ended. This example is called a snippet. A snippet doesn't have all your declarations and your initializations and all the rest of your code that you would typically have. It's just a very few lines or a very few statements, which again we call a snippet. So this is our single alternative. You have a condition and then you have your statements with an if. Our next one that we're going to go to is a dual alternative, which means you have a condition, and if that condition is not met, you will still do something. Some action will still be performed. So our syntax, we have our keyword if and then, our condition, and our statements, just like we had in our single alternative. Then we have a new keyword called else. So if this condition is not met, then it will run these particular statements. In other words, if this condition is true, it will execute statement 1 and statement 2. If the result of this condition is false, it will run statement 3 and statement 4 and end. So for our example, I'm just expanded the previous one. They've entered in their grade for project 1. If it's greater than or equal to 75, we're still setting pass to yes, and we're going to display you passed. However, if it's less than 75, it's going to come down and it's going to execute the else block. We're going to set pass equal to no and write you failed. So this is a dual alternative because it can be one. In this case, it can be true or false. If it's true, it's going to process the statements in your if block. If it's false, it's going to process the statements in your else block. And then the last one that we have is our multiple alternative. Our multiple alternative, the example I'm displaying here shows you many different alternatives. So a multiple alternative is 2 or more. In this case, same thing, if and then. We have our condition in between, and then we're going to run 2 statements. Again, it can be 1, it can be 2, it can be 100 statements. It doesn't matter. So if our condition is true, it's going to execute statement 1 and statement 2, and then it's done. It comes down to your end if. If this condition is false, it's going to come down and it's going to run the else if. Else if, and you have another condition. If this condition is true, then it will go through and it'll execute statement 3. If this condition is false and this condition is false, then it will come down here and it will execute statement 4. And this is a little bit different than you have in your book. In your book, it talks about nested if statements. Nested if statements are fine, but you have a lot of additional typing to do, and you have a lot of additional structure to work with. So I recommend using the multiple alternative structure versus the nested if statements. Using the multiple alternatives is better programming practice. It's more in line with the standards. In addition, you'll see in here that all of my statements are indented within the blocks. and my I lines up with my E and else, and my E and end if. Now, this may not seem all that important to you now. However, as time goes by and you have very large if statements, your if you go through and you line everything up, which you'll have to do as our good programming practices for your design documents, it will make life a lot easier as you go through and you debug your program. So our example that we have here is an expansion on our previous example where they're going to input the grade for project 1. But now we have it divided by their typical grading scale. So if it's 89.5 or higher, then they've earned an A. So my condition here is grade is equal to, greater than or equal to 89.5. Then we're going to display you've earned an A. And then I have my else if, grade is greater than or equal to 79.5, you've earned a B, and so forth. All the way down to my else statement, if it's not greater than 59.5, then you've earned an F. So this is a multiple alternative. Again, I really recommend you using the else if and always followed by a then using a nested if statement. It makes life a little bit easier as you're going through and you're debugging your program. The next one, or the last one, is a case. And the case statement is very similar to the else if statement. It performs basically the same type of functions, but it's the syntax is a little bit different. So you're going to have select case of, and these question marks are where you're going to go through and either put your variable or your value. Your variable makes more sense here. You can see that the comments here are, it's going to test the expression to be evaluated. So I have my case first value, then I have my statements under that, and then I'm going to use my keyword break to break out of the cases, and I'm going to go all the way down through as many as I want to. I come to my default, and then I have my statements at the end. So my example for this, which makes a little bit more sense, please enter your favorite color, input color, select case of color, again it's my variable. So if they entered in blue, then they're going to write blue is the color of trust and peace, and then we're going to break. If it's not blue, they're going to come down and look at the case where it's purple. So if my value of color has the value of purple in it, then this case will be true, and they're going to write purple is the color of imagination. If it's not blue or not purple, then it's going to come down to my case white. My white would be a match if they entered in white up here, and it tells you what the white value is, or the meaning of white is. And then it comes down to the default, and it just outputs no color match, and we're going to end case for that. And this is just a URL where I got this information from about the colors. So the case statements are very similar to the if statements. You can use either one that you want to, depending on your programming languages. Some programming languages say that the case statement is a little bit more efficient than the if statement. I grew up with the if, so you'll see me use the if a lot in class. So those were our alternative structures. Now let's talk about the conditions. The conditions you saw a little bit earlier, which is, my grade is greater than or equal to 75, my grade is greater than or equal to 69.5, all of those. The greater than or equal signs are relational operators. The relational operators listed here are the ones that we're going to use in the class. If you want to compare two values and to see if they are equivalent, you're going to use the double equal sign. The single equal sign is for assignment statements. The double equal sign is for comparison. And then I think that you're used to the rest of them, less than or equal to, greater than or equal to. This symbol right here is the exclamation, which means not. So this is not equal to. So it's an exclamation mark and an equal sign. So I think that you're good with the relational operators, the same thing that we used in math. This slide is again just re-emphasizing the fact that a comparison operator is two equal signs. The assignment operator is one equal sign. The assignment operator takes what you have on the right-hand side of your equal sign and stores it in your variable on the left-hand side. The double equal signs will take the two values on the right and left and see if they are equivalent. The next thing that we're going to go over are logical operators, because there are times when a simple condition is not going to be enough for you. You're going to have to go through and you're going to have to use a more complex condition, and these are called compound conditions. The simple conditions contain one relational operator. A compound condition reduces the amount of code that must be written. So you don't have to say if it's greater than this and if it's greater than that, else if it's less than this. You can go through and you can combine all of those into compound conditions using your logical operators. The logical operators are and, or not. The ones that you're going to use the most are the and the or. So let's go through and let's explore those a little bit further. The and. So here we have our syntax where we have condition 1 and condition 2. These conditions have to be full conditions, which means they have to stand on your own, and we'll cover that a little bit more. So it's the same if statement. This is just a single alternative structure. If my condition is true and if my condition 1 is true and my condition 2 is true, then it will run statement 1 and 2. An and means that both conditions have to be true for it to execute, in this case, statement 1 and statement 2. So here we have in our example, please enter your year in college. Please enter your major. Again, this is a snippet. If your year equals double equal sign equals freshman and major equals computer science, then please attend orientation in the ATC, else please attend orientation in SUW. So the Student Union West. So if I'm not a freshman or my major is not if my major is not computer science, then I'm going to attend orientation in the Student Union West. If my year in college is freshman and I'm a computer science major, then I'll go to the ATC. The and again means both these conditions have to be true. Here I use the double equal sign to make sure that those values are equivalent. My next one is my or. In my or operator, you'll see we have almost the exact same syntax, except for my compound operator or my logical operator is or. So if my condition 1 is true or my condition 2 is true, what it's saying here is that if my condition 1 is true, it will execute this. If my condition 2 is true, it will execute this, regardless of what my condition 1 is. So for my example, same thing. If my year in college is freshman or my major equals computer science, then please attend orientation in the ATC, which means that all freshmen and all computer science majors will attend orientation in the ATC. Because if I'm a freshman, that's true. Remember, the or, only one of them has to be true. So since this is true, it will automatically execute this statement. If this is false, then it will come in and it will ask if my major is equal to computer science. If it's equal to computer science, again, this whole equation condition is true, and it will run this statement. So that was the or operator. With the or operator, only one of the conditions has to be true. The last one is the not. Again, I don't use the not a whole lot. So we're having if not condition, then statement 1 and statement 2. So if my condition is true, then I have my not in front of it, which then would change that to false. It would not run either statement 1 or statement 2. If my condition is false, and the opposite of false or not false is true, then it will execute statement 1 and statement 2. You can see how kind of confusing it would get, and I think there's a better way to write your logic than using the not statement. So here we're going to go through, we're going to enter your year in college, input your year in college. If you're not a freshman, then please attend orientation in the ATC. So if I'm a freshman, I'll attend orientation in the Student Union West. Because if this is true, the not of that or the opposite of that would then change it to false, which would come down and run this statement. So those are the and, or, and not operators. They are used for compound statements. A compound statement means that you're going to use that logical operator in between simple conditions. So this is very important. If count is less than 5 or count is greater than 10, is not the same as the statement down here. What we have is we have a full condition, count is less than 5, or something is greater than 10. In this case, this side of the right side of the or is not a full condition. You want to make sure that they are full conditions on the side of your logical operators. So count is less than 5 or count is greater than 10. So the order of precedence, and I'm going to let you go through, this is up there, you can go through and you can take a look at it. It's in your book, it's from the chapter slides, but this will go through and just let you know what goes first. So we can see with the relational operators, we have less than, or equal to, greater than, equal to, same as, not the same as. And then our logical operators, not is execute first, then and or. And you can use the ampersand or the double pipe or the actual word spelled out in uppercase or lowercase. It doesn't matter to me as long as you're consistent all the way through your program. We talked about Boolean variables or Boolean data types at the beginning of class when we went over the 5 different data types. So a Boolean variable may be either true or false. So that's a Boolean variable that's a variable of data type Boolean, and it can have the value true or false. You do not have to put these in strings, and you don't have to do a comparison. So the example down here is we're going to declare answer as a Boolean, and we're going to assign it to the value of true. Then if answer, then you'll notice there's no comparison here because answer in this case would equal true. All we're looking for in our condition in our if statement or any other conditions for that matter is for them to equal to true or false. And since answer equals true, we're going to write you are correct. So those are Boolean values. You can use them however you see fit. The next thing that we're going to talk about is really testing your decision structures. We've already talked about hand tracing. We've already talked about the fact that you have to go through and perform your calculations manually or with a calculator in your test data before you actually go through and run them. The only thing that we're going to add here is that you want to test each one of your branches of your if statements. So if we come back to where we tested the grades, if the grade was equal to greater than or equal to 89.5, you want to make sure you have a test value for this one, for this one, for this one, this one, and this one. So you want to make sure that you test every single decision structure or decision branch with that. And the last thing that we're going to talk about are the menu-driven programs. And menu-driven is changed a lot over the last few years. But really what you want to do is you want to make your program user-friendly. The user can go through and can select from many different options. They can enter a value or they can select values in a checkbox and a radio button. They can use drop-down menus and you can use hyperlinks on web browsers. So the user can go through and choose or select any of those. For us, what we're going to do is we're going to go through and we're going to use a menu-driven program. So for example, we're looking for the inventory. So the options are leave the program, the user will enter 0. Add an item to the list, enter 1. Delete an item, the user would enter 2. So this way the user doesn't have to go through and enter all this information. Remember, users will go through and will make mistakes. So you want to make sure that you give them an easy way to go through and enter the information. The best way to do that is to go through a menu to accomplish this type of stuff. So this is a sample that we have here. In the example for chapter 4 where we expand on the tip calculator program, you'll actually get to see this in the menu driven space. And that's all I have for chapter 4 on the lecture part. I would strongly encourage you to go through and watch the tip calculator. This will actually apply all the information that we have covered in this video.